Okay, so now we're going to find the domain of this function, and I've called it a radical rational function. I don't know if that's really a term, but it's a composition. You've got a radical square root, and then you've got inside, you've got this rational part. The radicand is a rational function, if you will. Okay, so we know because it is a radical that the radicand, x plus 2 times x minus 3 over x minus 1 has to be greater than or equal to 0. It can equal 0, that's okay. Oops, it looks like I have a little marking there. We can think about what that graph looks like because it's a rational function and we've worked with those before. So we know there's going to be x-intercepts at -2 and at 3. So we can draw those in. -2, 3. We also know there's a vertical asymptote at x equals 1 because you can't have the denominator equal 1. So there's our vertical asymptote. And we also know the y-intercept. So if you plug in 0 for x, you're going to get 6 is what you're going to get. So we know there's a vertical or a y-intercept at 0, 6. And so because the multiplicities are all 1, we know that the graph is going to run, up here toward the asymptote, and then it's going to go the other way from the other side. So it's going to look something like that. Now, we know there aren't any other x-intercepts, so that kind of tells us enough to know what we want. We want it to be greater than or equal to 0, so we need it to be positive. So we need this section here, which is going to be, so this is our domain, it's going to be from 2 to 1, and then we need the positive portion over here, which is going to be from 3 to infinity. And so you could do it that way. Now if you're wondering, hey, this looks like, another type of problem we did before, you could do it another way. You could say, let me write this out again. Here's my number line, and I know I have critical values at -2 and 1 and 3. It can equal -2, it can equal 3, but it can't equal 1. And then you can do the test points. So you could plug in like a -3, which would give you, let's see if I can scroll this up a little. You'd get a negative times a negative divided by a negative. And is that greater than or equal to 0? No. And then you could try, so this is no. Then you can try a point between -2 and 1, so maybe 0. That would give you a positive times a negative divided by a negative. Is that greater than or equal to 0? Yes. And then you could try a number between 1 and 3, like 2. That would give you a positive. Whoops, this is supposed to be a 3 there. A positive times a negative over a positive. Is that greater than or equal to 0? No, that's going to be negative. And then you could try a number like 4. That would give you a positive times a positive over a positive. Is that greater than? Yes. And then you'd see the domain is going to be the same thing that we just had, -2 to 1, union 3 to infinity. So either way, you could look at it 2 different ways.